So in this video, we're dealing with Quadratics Quiz number 5. We're just going to go over how to do 6 problems, and hopefully you'll get these problems will be helpful when you're taking your quiz. The first question says, what are the zeros of the function? So we have a quadratic function here. So if that says h of t, all I have to do is just set it equal to 0. So we've got negative, open parentheses, t minus 7 squared plus 4. So what I'm going to do first and foremost is I'm just going to simply, let me get here, there we go. I'm going to take away a 4 from this side, take away 4 from this side, get negative 4 equals negative t minus 7 squared. Now if there's a negative on the other sides of the opposite sides of this equal sign right here, they will eventually cancel out. So if I divide both sides by negative 1 like this, they'll cancel out. Or if I multiply both sides by negative 1. So essentially what I'm going to do right here, just to make it faster, is just going to say, it's going to change both of those to positives. What do you do to one side, you do to the other. So right now we have 4 equals t minus 7 squared. And then I'm going to take the square root and the square root. So the square root of 4, I'm going to put plus or minus 2 equals t minus 7. And the last and final step is I'm just going to add 7 to both sides. So my final answer is t equals a 7 plus or minus 2. So what's my solution set? Well, what is 7 plus 2? That's a 9. And what's 7 minus 2? That's a 5. So my smaller value of t is 5, and my larger value of t is 9. And that's all I have to do, all right, to make it equal to a 0. Now this is actually in vertex form. If you don't know what vertex form is, I'll just write it. I'll put, a lot of times you'll see f of x. It's a parentheses x minus h squared plus k. It looks like our h value is 7 and our k value is 4. So that's the vertex here. So I'll highlight. It says x minus h, that says t minus 7, so that's the h value, and then the k value is right there. It's just at a 4. So the h value is the x value of the vertex. The k value is the y value of the vertex. All right, so there we go. Smaller 0, I believe, was a 5. Larger 0 was a 9. Vertex was at a 7 and a 4. All right, there we go. Question 1 done. Now we're going to graph this function. Okay, so this is in standard form, and in standard form that always reveals your y-intercept. So I know my y-intercept's at a 0 and a negative 6. So if I have a function g of x equals negative x squared minus 6x minus 6, and I didn't have a graphing application like Desmos or a graphing calculator, here's how you could do it by hand. If you know how to use Desmos, you can just type it in and you can easily graph it, but I'm going to show you how to do it by hand. So right now I know it's going to be a 0 and a 6 because that's the c value. If you're like, what the heck is the c value? Ax squared plus bx plus c. Okay, the c value is always your y-intercept. Now I'm going to find my vertex. Now to find the vertex, there's a special little formula to find the axis of symmetry. That's negative b over 2a. All right, so you got to know what your a value is. My a value is negative 1. My b value is negative 6, and my c value is also negative 6. So if I take these numbers and I plug in a negative 6 in for b, a negative times a negative is a positive over 2 times negative 1. So I get 6 divided by negative 2, which is negative 3. So I know my vertex is at negative 3. And now what I have to do is I take that negative 3 and I plug it into my formula. So we go. Won't take long. Just plug in negative 3 wherever there's x. Now a negative times a negative is a positive. So it's a positive 9, but there's a negative sitting out there. So that's going to be negative 9. And a negative times a negative is a positive, and then a minus a 6. So you could do this in your head if you wanted to. You could say 18 minus 6 is 12, and 12 minus 9 is 3. That's one way. That's one way to do it. You know this graph's going to be opening down because of that negative sign. So I'm just going to take these 2 points right here. So by the way, this is how you find your axis of symmetry right there. That's a nice, neat little formula. You could use negative b over 2a. So I'm going to go ahead and graph this. We're at a negative 3, positive 3. And we're at 0, negative 6 right there. Now I want you to see, before I hit check, I want you to see there's that axis of symmetry at x equals negative 3. And how do you find the axis of symmetry? Whoa. Right here, that is always x equals negative b over 2a. Now, to check your work, you could go over here and go to Desmos and just type it in, negative x, see if I can get that. There we go, negative x squared minus x minus 6, or what was it? Oh, 6x, I forgot to put a 6x, my bad. 6x, there we go. And you can see right there, there's your vertex, there's negative 3, 3, and then there's your y intercept right there, 0, negative 6. So you could obviously type it into Desmos and easily graph it. Always graph your vertex and one other point. So there's my vertex and there's one other point. We're going to graph this function, except we're not going to do it using Desmos. We're going to show you how to do it by hand. It's very, very, very easy. You'll notice right here, you could put plus 0, so I know my y-intercept is literally at 0, comma 0. That's my y-intercept. All right, so I know I'm going to have a point at 0, 0, so I'm going to make a little table. 0, 0. And now I'm going to find my vertex. So here we go. I'm going to use the same method, so maybe this time it'll make even more sense. So right here, my A value is 1, my B value is 2, and my C value is 0. So I'm going to find the axis of symmetry doing negative B over 2A. All right. So my B value is 2, so I'll put negative 2 over 2A. 2 times 1 is negative 2 over 2. So my axis of symmetry is at x equals negative 1. All right. So that's how I find my axis of symmetry. Now all I'm going to do is I'm going to take that negative 1, I'm going to plug it in. So instead of x squared, I'm going to put negative 1 squared. Instead of plus 2x, I'm going to put plus 2 times negative 1. That becomes 1 minus 2. 1 minus 2 is negative 1. So my vertex is actually going to be at negative 1, negative 1. So I'm going to have a vertex right here, and I'll have a 0 right there. So here's what it looks like. Negative 1, negative 1, 0, 0. Just like that. Now, like I said, if you want to check it, go over here. Just type in x squared plus 2x. And you'll see there it is, negative 1, 0, 0. And you are good to go. All right. It says, which form reveals the zeros or the roots of the function? Well, that's factored form. Okay? So we're going to go over the different forms real quick. Ready? This is called vertex form. And you know what vertex form reveals? My class better know what vertex form reveals. It reveals the vertex, which is the h and the k value. So this hk value for this particular problem would be at a 2 and a 27. Boom, done. This is standard form, and standard form only reveals one little thing about the graph. Standard form reveals the y-intercept, and that's the c value right there. So the y-intercept would be at 0 and 15. Now factored form reveals the zeros. So that's the answer. All right, so what are my zeros? My zeros are like, what number would you plug in there to make it equal to 0? Negative 1, what number would you plug in there? A 5. So my solution set is negative 1, comma 5. It didn't ask you for the solution set, but those would be my two zeros for this problem. Oh, it says write one of the zeros. Cool, so one of the zeros is 5, and one of the zeros is -1. So I'm going to put -1. So we got to do two things. That's cool. I like it. All right, so here we go. So that reveals the zeros, and one of our zeros, what number could you plug in there? A -1 or a 5. So I'm going to be, 5 is easy to plug in. Let's plug in -1. Nailed it. Good job. I'm going to go ahead and pause the video. All right, so in this problem it says Ingrid hit a golf ball. The height of the golf ball in meters above the ground is being modeled by this function. Ingrid wants to know when the ball reached its highest point. So it says rewrite the function in a different form, factored or vertex form, where the answer appears as a number in the equation. All right, so we got to reach its highest point, so we got to change this to vertex form. So I'll show you guys how to change that to vertex form right now. Okay, so we have h of t equals -5 t squared plus 30t. Now this is in standard form. We got to change it to vertex form. So here's what I'm going to do. Put empty box plus y. Just changing that to y equals -5 t squared plus 30t plus an empty box. We're going to learn that we're going to complete the square on this. All right. Now when you complete the square, here's what you got to know. You got to be able to factor out that -5. So we're going to factor it out. That leaves us with t squared minus 6t. I'm going to put the empty box here, and that's, since there's nothing at the end, there's nothing at the end, so I'm just going to leave it exactly right there. Okay. Now, to complete the square, I got to take half the b value, and I have to square it. So half of -6 is -3, and -3 squared is, all right, so if I put a 9 here, I want you to understand that this is the c value, but that is being multiplied by a -5. So I actually have to multiply -5 times the c value. So what is -5 times 9? That's actually -45. So this is the c value, but this c value is being multiplied by a -5. All these numbers are being multiplied by a -5. So I want you to understand you got to put a -45 over here. So I'm putting -45 plus y equals -5. Now we need to know how to factor this guy right here. We're going to factor him to t minus 3 being squared. And the last thing I'm going to do is just add 45 to both sides. I was a little messy there. I'll go ahead and clean it up a bit. There we go. So our final answer is this. h of t equals -5 t minus 3 squared plus 45. Now that means my h and my k value, this is vertex form, my h value is 3, my k value is 45. There's my vertex. So this graph goes up like this and comes back down. And if I were to type this into Desmos, there would be my vertex at a 3 and a 45, which basically means after 3 seconds it gets to a height of 45 meters. Okay? So right now, I'm going to go ahead and finish this up. I'm going to go ahead and pause it right now. So I'm not sure where I was in the video. I had to pause the video. I had a new class come in. All right, but we have to rewrite the function in factor to vertex. We're going to write it in vertex form because we're going from standard form, and it says where is it going to reach the maximum height. So I'm going to go right over here, and I'm going to write down my answer right here, which is in vertex form. And then over here, it says how many seconds after being hit does the ball reach its highest point? Well, that's that number 3. After 3 seconds, it reaches a maximum height of 45. So I'm going to go over here and I'm going to type this in nice and neat, and I'll see if I've changed everything to vertex form, completed the square correctly, and all that good stuff. So here we go. I believe I had a -5, open parentheses, then it was t minus 3. Then I right arrow, I squared that sucker, and then I put a plus 45, and then it was 3 seconds after being hit, it got to its maximum height. So let me make sure I did that right. Looks like I did. Looks good. I feel good. I feel great. I feel wonderful. Oh, I got a student that had the same question. Lucky her. Lucky her. Okay. Now, this question says the power generated by an electrical circuit in watts as a function of its current X in amperes is modeled by this function. It says, what is the maximum power generated by the circuit? So please write this one down, everybody. Write this one down nice and neat. Oh, not that. This. So we're writing down P of x equals negative 12x squared plus 120x. What are we looking for, people? Maximum power. Yes, effort in the class. We're looking for maximum power. So would you guys agree, if I made a little tiny sketch of the graph, what point would I plot on the graph that represents the maximum? The vertex, right? Now, is it talking about the x value of the vertex, or is it talking about the y value of if it's talking about the maximum, it's talking about the y value of the vertex. That's what we call the maximum. The x value would be the current that produces the maximum. That would be the x value. Now, let me go show you guys. Now, normally, what have we done? We've completed the square and changed it to vertex form, but I'm going to show you a shortcut by hand how you can find the vertex without having to change everything and completing the square. You guys ready? Here we go. X equals negative b over 2a. If it's in standard form, I would use this, and sometimes it's faster than completing the square. So write this equation down. Write x equals negative b over 2a. Label this. This is your formula for the axis of symmetry. All right. Can anybody in my standard form tell me what a is in this particular function? Negative 12 is right. What about b? What's my b value? 120. And my c value, I don't see it. 0. There we go. So far, so good? All right, now check this out. If I say negative b, which is 120, over 2 times my a value, which is negative 12, you guys in the calculator right now could probably do negative 120 divided by negative 24 and get me the number for the axis of symmetry. Did you guys get 5 when you did that? Negative 120 divided by negative 24? Is that 5? It's 5. Good. All right, good. Now, what I want you guys to do now, wow, I already have students yawning. Okay, I want you to take that 5 and I want you to plug it in here and plug it in here, and that actually gives you the maximum. Okay, that gives you the maximum right there. So check this out. We're going to take negative 12. I'm going to open up a parentheses. I'm going to put 5. I'm going to square it plus 120 times 5. So if you guys would help me out here, do negative 12 times 25 plus 5 times 120, which is 600. So what is negative 12 times 25? What's negative 12 times 25? Negative 12 times 25. Help me out. What you got? Negative 300? Okay. Plus a 600 means the maximum power would be 300. So in vertex form, if I wanted to convert this to vertex form, where the vertex I know is at a 5 and a 300, here's what I could do to change everything to vertex form without having to complete the square. Okay? Here's my answer in vertex form. Ready? Put y equals, for the whole p of x, I'm put y equals negative 12, open parentheses, x minus 5 squared plus 300. I just changed it from standard form to vertex form, and what did I not do? I did not complete the square. Okay? So I'm going to type in 300 for the answer. But before that, if you guys write this down, we're going to type this into Desmos so I can prove to you that what I just did was... Oh crap, I just told the student I could use Desmos. Dadgummit. All right. So help me out. Help me out. Tell me the original equation. It was what? Negative 12x squared plus what? 120x. And I have to zoom way up high. What's the vertex? 5, 300. And what did I say the vertex form was? I said it was negative 12, open parentheses, x minus 5 squared plus 300. Does everybody see how these, ding, 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 those are the exact same? All right? So that's how you guys would do it. But if you had no access to any graphing elements and you had to do it by hand. Okay? But if you have access to a calculator, obviously, but there are certain tests you can't use calculators. All right? So what's the special formula? I'm going to highlight here the what? The axis of symmetry. Now, what does the axis of symmetry do, guys? What's the purpose of it? It splits that parabola what? Right down the middle. I'm trying to do it. Maybe a third time's the charm. I don't know. Nope. Fourth. That's not bad. Okay, so the axis of symmetry always passes through the vertex. So if I find the x value, then I can plug it in and I can find the y value. So 300 watts. So I'm going to go over here, type in 300. That's how you get 100. All right.